My name is Chris Newman. As Sean said, I'm a professor of law here at George Mason University. We are going to discuss sort of the status quo of IA research. We have a great panel of four very knowledgeable individuals from different perspectives and different professional interests in the field. And so, as Sean said, we're going to do very brief introductions of each one just as they begin speaking. And so we're going to start off with Dr. Woodrow Barfield, who is the associate editor of the Virtual Reality Journal, senior editor of Fundamentals of Wearable Computers and Augmented Reality, and visiting faculty at the University of Turin. Go ahead and take it away, Woody.
Thank you very much. So I'll just put my my slides up so that everyone can take a look. Well, it's great to be here, and that was a great talk by Ryan, and there will be a little bit of redundancy in my talk with his. But by and large, I'll try to say some things that are new and hopefully interesting and that represent my thinking on artificial intelligence and intellectual property. Okay, so if this was an interactive session, I'd ask everybody, why a pizza in all these slides or in all of these books? Well, my background is engineering and then law. So the engineering came first, the law came second. At the top are a bunch of books that I've been working on and produced with a lot of great co-authors and people that contributed chapters in the last 4 or 5 years. And the bottom books represent my interest in human enhancement technology, and particularly the law as related to human enhancement technology. But then there's a pizza. So what the heck is a pizza doing in this talk? And I'm just trying to point out that instead of wouldn't want people to think I'm shamelessly hawking my own books, because I can tell you, if you all go out and buy the books, I think I will order enough royalty. I'll get enough royalties from the publisher that I could order a pizza. Okay, so in this panel, we're really asked to talk about a very broad topic, and that is what can artificial intelligence do now, and what may it do in the future? And again, Ryan spoke about these issues. So for those of you out there that would like to know about a textbook where you could learn more about AI from a computer science or engineering point of view, this book by Russell and Norvig is a top text that's used in a lot of universities, an introduction to the topic, probably at the junior or senior level of computer science or engineering. And even if you have a law background, I think that if you want to get technical information about AI, different techniques, this would be a good place to start. Okay, so I think that this may be my most, first of all, apologies for having a little bit crowded slides, but this may be the one that I find most interesting and want to dwell on a little bit. And essentially, this is talking about what AI may do now and what it may do in the future. So the idea is that artificial intelligence requires lots of computational resources. And so the more computational resources, the trend has been the more that AI can do. So if we look at this curve, it's called the Kurzweil curve. You can see an exponential growth in computing technology. And Kurzweil is a person who makes a lot of predictions. He predicts that by 2050, we may have a $1,000 laptop with the computational processing power of a human brain. All right, so this is exponential growth in computing power. Computing power is really important to create lots of different applications and developments in artificial intelligence. So let's think for a minute about exponential growth, because I think that's incredibly important for this conference. So the opposite of, or the other way to look at things is not exponentially, but in a linear manner. And so that little cartoonish image that I have shows, if you're thinking about the world in a linear way, and you think, what's the world going to be like 4 or 5 years from now, 10 years from now, you just extrapolate in a straight line and it won't be too much different. But due to the exponential growth in computing technology, where actually the futures could potentially be much different than now. AI may be able to do a lot more than we could even imagine today. Again, let's think about exponential growth for a minute. If you increase something by 10, it's 1,000 times increase. By 20, it's a millionfold. And if you double 30 times, it's a billionfold increase. So clearly, Moore's law has resulted in what? A billionfold or more increase in computing power in the last several decades. And here I'd like to ask for a volunteer. I'd like to ask Sean to volunteer, to raise your hand virtually, Sean. And I'd like you to take 30 steps linearly and get up and do that and then come back. So, okay, he did it.
How many steps am I doing?
30 steps linearly. How far have you gone?
Oh, I haven't gone very far at all. I'm standing here listening to you. Do you want me to actually walk?
Nope.
Okay.
So we're doing it as a thought experiment, and you just went about 90 meters. So you took 30 steps linearly, you went about 90 meters. Now I'd like Ryan to raise his hand and volunteer, or I'll volunteer him. And I want him to take 30 steps exponentially. And I'll tell you what, 30 steps exponentially means we're going to go to the circumference of the planet, and he's going to walk around the planet. He's going to circumscribe the planet approximately 26 times. So that's the difference between linear and exponential. And computing power is increasing exponentially, and that's giving AI the resources, the computational ability to do the interesting thing that's going to do. It also makes it really difficult to kind of predict what laws should we think about regulating AI as it exists now, or as that it may exist in 5-10 years, because that could be 2 or 3 doublings. The doublings at this stage of the game result in a tremendous amount of more computational resources to do interesting things. So related to that idea, the idea of exponential increases in computing power, is this cartoon that you may have seen or not. And it's really, imagine a person sitting at a desk, and their task is to write down all the things that humans can do right now better than AI. So maybe humans are better at common sense than AI. So you write that down and you stick it on the wall. You know, maybe humans are better at going to a Broadway play and writing a review. You put that on the wall. So, and then of course, from the Jetsons cartoon, there's Rosie the robot. It's a very sexist looking image as we look at it through the eyes of 2021. But we're still waiting for a robot like that to be a maid in our home, and it hasn't happened. But the point is that if you look at the floor, all the things that you thought AI couldn't do and only humans could do is slowly being taken off the wall and thrown on the floor. And the number of things left that humans are clearly superior at compared to AI is becoming smaller. So what are some of the examples? Again, Ryan brought up a bunch of things, but facial recognition technology, robot pets, robot surgeons, robot investors, artificial intelligence creating music, artificial intelligence creating copyrightable material, and other applications as well. So the idea that humans are better at common sense, well, there's a 2020 paper. And the title is Enabling Robots to Understand Incomplete Natural Language Instructions Using Common Sense Reasoning. So there's a lot of people doing research to try to get robots and artificial intelligence to do the things that humans are better at now. The other paper that you see is a robot playing catch and juggling. A humanoid robot doing that, that's a difficult thing to program a robot to do. My daughter will be giving a talk at a robotics lab at Georgia Tech later this month, and they have a robot in the lab that plays ping pong. Okay, so this is a fairly optimistic view of AI. You know, it's giving you the impression that AI is going to be able to do anything a human can do as good or better. So very optimistic view of AI, but not everybody, of course, thinks that way. Some people think that there are human skills that AI will never be able to do. And even somebody like Rodney Brooks, who's the former director of MIT Robotics and Artificial Intelligence Lab, he indicated that AI as it exists now has basically 2 main components. So either it has a person somewhere in the loop. So when you're driving an automated car, it's not, there's still a steering wheel. You can still take control. Or if the cost of failure, then possibly there's no human. So maybe if the system doesn't, if it fails and it's not, the outcome is not deleterious, then possibly that kind of system doesn't have a human in the loop. So this is the state of the art. This is where we're at now, by and large. So continuing the thought about the exponential growth in computing technology and where that's heading to. And again, I think Ryan alluded to this a little bit in his talk. So I arbitrarily wrote down two numbers, 1980, two dates, 1980 and 2050. I'm perfectly happy to move those numbers to the left or right by a century or two. It doesn't matter. The planet is 470 million centuries old. And we move that around a little bit. It's just a rounding error. So arbitrarily, I wrote down 1980. Let's say that before that, humans were clearly superior to AI in all tasks. And our legal system is primarily designed for that type of world. Then let's say that what if around 2050, as Ray Kurzweil, from the Kurzweil curve I just showed you, predicts that something called the AI singularity occurs. So that's a point in time when AI will reach and then surpass humans in general intelligence. Okay, not 2050. I'm willing to move it to 2150 or even 2250 again. That's just, to me, a rounding error. But if that were to occur, the issues brought forth by AI reaching and surpassing humans would be incredibly challenging and incredibly interesting. We may not be making laws for AI. Possibly AI would be making laws for humans. So between 1980 and 2050, that's the time period we're in now. And I argue that this is a time period of mutual cooperation. This is a time period where we say, look, one analog brain, which consists of 100 billion neurons, 100 trillion synapses, working with a digital brain that may be operating supercomputers at petaflop or exaflop computing range, combined can do something better than either could do alone, because each have unique abilities. One's much faster, one's a little bit better at pattern recognition right now. And together they produce something that's better than they could individually. That's the time period we live in now, I think. And what happens if the AI clearly surpasses the human in intelligence and we no longer need to work with AI in a completely mutually cooperative manner? Well, some of the issues are, for example, tort issues right now. As AI gets even smarter and more autonomous, we're having lots of conversation and assigning liability. Who's responsible? If you can't place a human as responsible in the loop. Okay, so again, about the mutual cooperation period between 1980 and 2050, lots of books are being written, lots of articles being written, and supporting the idea that we're living in a time of mutual cooperation between AI and humans. Okay, so again, to our theme, what AI can do now and what it may be able to do in the future. So this looks like a timeline on this slide, but it's actually not really meant to be a timeline. And so all of these things could be basically a dot or superimposed, but of course, then you wouldn't be able to see them. So all I want to point out in this slide is that, and I jumped ahead one. So I want to point out that we have automated guided vehicles. They're getting smarter. Government agencies are using AI for lots of decision-making. We're creating smart homes. We've got robots that are dexterous and walking up and down stairs with lots of intelligence. And then there's something to the far right that's a particular interest of mine, and an idea that I've been proposing is the idea that artificial intelligence is migrating. It's migrating from the external world to the internal world of the human body. So here's a person that can manipulate a robotic arm, a prosthesis, by thought. And we're also developing, in the early stages, artificial hippocampus, artificial prosthesis that would potentially allow a third party to access a person's mind. And of course, you use your mind to invent and to write and to think. And that would raise all kinds of questions in cognitive liberty, First Amendment free speech rights, and all of that. Okay, so in this slide, kind of a big picture idea. I personally think of AI as a superordinate technology that controls a lot of subordinate technology. So there at the top of this so-called triangle of technology is artificial intelligence. It's controlling robots. It's the brain of robots. It's the brain of other AI-enabled technology. And it's the brain. It's the one in control. So a few years ago, a colleague of mine, Ryan Kalo, suggested that we develop. Ryan's an expert in AI, robotics, and law, but he suggested that we develop a federal robotics commission what I would say is move the arrow up and point it at AI and call it an Federal Artificial Intelligence Commission. Because again, I think that artificial intelligence is a superordinate category controlling things that are subordinate to it. But that doesn't mean they're not important and that we don't need to regulate them with law. But the question is, do we regulate AI and by extension, all the things underneath it, or do we specifically look at law specifically for robots, specifically for other AI-enabled technology? Those are policy decisions that we have to talk about and decide. Okay, so lots of people attending this audience may not be thinking about artificial intelligence on a day-to-day basis, and if not, you may be wondering where to find more information. And I just want to point out that this is a growing field. There are lots of conferences being held, and you can pick the topic you're interested in. Stanford had something on AI and free speech a few years ago, and if you're interested in AI and intellectual property, there are conferences on that. There are also, if you're interested in AI itself, and you just want to keep up with the technology, such as machine learning or natural language processing, you can find conferences to attend on that as well. So I think that's about the time period I have. Thanks for listening. Let's have an interesting session. And I've left you my email. If you have any, if you want to email me offline or at any time, that's fine.
All right, thank you, Woody. And just to remind everybody, there's a Q&A window at the bottom of your screen. If you want to type questions into that, we're going to leave some time at the end to get into questions. All right, next up, we have Susan Hallen, who is Associate Partner for Sales and Delivery at the AI Workflows Center of Competency for IBM Watson.
Great, thank you. Thank you for having me. And I'm going to take this in a little bit of a different direction and talk about more of the business aspects. So IP business as a whole includes understanding the market, the competitors, the technologies in order to create your own strategy, understanding your portfolio, your competitors' portfolios, technology trends, new entrants in order to commercialize all of your investments. Overall, with AI, we're seeing increased accuracy, we're seeing increased speed, so minutes to get your first results, interactive comparisons, transparent knowledge of what the AI engine really understands, and then uses for comparisons and searches. But let's apply AI into the world of IP in 7 primary areas. The first one is trend analysis. So what are the technology trends? Big data, AI analysis of research, presentations, patents, company publicly available, anything that you can bring in. One example, our Tokyo Research Lab is using Watson and AI open source tools to do patent trend analysis, to understand changes in terminology over time, new technologies entering the space that may not have really good definitions in any of the models, trends in what areas of innovation are happening around a technology. So how do you know where your company should invest? How do you know if you're looking for a new area, how to find information? The trend analysis helps with that. The second one is competitive analysis. So who are the players? Who's coming in? What more do you know about them? And not just from a patent view, but from a public information view. Look at their 10K, look at their annual report. Where are they investing? All those things combined into not only what they're talking about, but do they have the patents to back that up? Gives you a pretty good indication of where they're going and what's going on. So text summarization, classifications, concepts, categorization, all helps within that area. Portfolio analysis is the third one. So you talk about what's in your portfolio today. What do you need to support a new and changing business strategy? Can you partner to get it? Do you need to buy it? Do you need to license it? All the AI tools around IP can help you narrow that down. So using it to find similar art, crowded spaces is much more complete than using semantic or keyword searches. So you want to be able to have a much broader view and find things that you wouldn't normally find in a semantic search. Basic search for prior art, for evidence of use, for similar patents is another area. So by leveraging this ingestion and understanding, machine learning, neural networks, NLP, so natural language processing, and elastic searches, you can get a very good detailed result very quickly. And so you can leverage that to get beyond a keyword search, get beyond the analysis, and be able to side by side see what really matched and why. Why are they important? And so you not only find a list of here's the patents to look at, but you can look at them automatically and have it narrow it down. I can bring in documents and compare them to my patents and do that side by side so I can see where is my evidence of use at. The fifth area is really patenting AI innovations and invention creation. I think you've heard a lot about that already in the first session. But you think about if the AI is coming up with the idea, can that be an inventor? That's already been talked about a lot. I won't go into it, but you need to think about what that means for the future and are the laws keeping up with it, which they're not right now. The second part of that is actually patenting an AI innovation. So the algorithms, the models, the applications around them, you've got to figure out what part of that technology, not only is it novel and patentable and discoverable and all those other normal things, but you also want to take a look at what's the longevity of that. So is it worth patenting an AI model that's going to change in 2 months? Probably not. So you need to look at how fast things are changing now versus what it takes from a cost perspective and a time perspective to get some patent. So people are looking at all kinds of other ways to protect that IP. Software patents provide some logical basis for AI patents. That's really the starting point. We tend to focus on the algorithms. Every company's a little bit different. Prosecution. So there's a lot of companies out there that use AI to create a template or a initial response to an office action. But take that deeper. Gather all the data together, do the analysis at once, and then create your potential responses faster. Think about using AI to give you, here's 5 strategic ideas for how to respond to this and what the implications might be downstream. That's not there yet, but we're headed in that direction. And so you're going to see a lot more in the prosecution space. The last space that I'll talk about is contract analysis. So some parts of document analysis are very, very mature right now, in use at a lot of companies. When you combine those intelligence systems with a normal contract lifecycle management system or CLM system, you get that for your end-to-end work, and it helps out a lot. But you want to do some classifications based on annotations. You want to look at document types, the contents, comparing contracts across a corporation. So if you want to look at, I have 1 million contracts out there, what are my IP clauses and which ones give me the highest risk? That's where you want to apply AI to these, to have it do all the work for you and identify not only clauses that are different, but clauses that have a higher risk value. So you can apply AI in many directions. So that's a very quick summary of the kind of things that we see AI being used for in the AI space or in the IP space right now. But all those functions can come together. If I take licensing as an example, right? When I'm doing an IP license or a patent license out there, I want to identify potential infringers. AI can help you do that. We want to identify the patents that you need to fill your portfolio. I might want to find evidence of use. I might want to look at the company and the business information. Can they afford to pay me? Do they have the same product values that I have? Are they going to protect it and use it the way I think it should be? What am I going to do with that? I want to look at the white spaces and landscapes for my portfolio. So AI really helps in all of these things by using natural language understanding and neural networks, by being able to ingest and read and understand big data in the number of files, the number of data, right? If you look worldwide, there's 137 plus million patent records, but there's also a slew of non-patent publications. How do you get through those? Right now, you do it with a keyword search, you find a section and you go from there. What if I had this do it for me that not only found that section, but found 5 other sections that were related to it? That's where AI comes into play. So as we talk about that, there's one primary challenge for this. Well, not one, there's a lot, but the biggest one is trust. So how do you trust a black box? What's the reasoning? How was the system trained? Is it secure? Is it transparent? You've got to trust that the AI system you're using to do any IP analysis understands the context, it's free of bias, it's trained by valid and relevant data and people, and it's very secure and it's transparent. So you know what the basis is that it's making its decisions on. This is where ethics comes into play and into the discussion. So most large companies, including ours, we've got an AI ethics policy today. Everyone should. Typical pillars in that are accountability and value alignment, explainability, fairness, user data rights. Everyone should be headed towards some kind of ethical platform and policy. So we look at AI today as augmenting the professional. So as you just heard from Woody, there's a lot of ideas around what can AI do today, what can it do in the future, and we would add what should it do in the future and how should it be used. That comes into the ethical bind that you get into. We think right now it should be another tool in your toolbox, not a complete replacement of humans. Right now, there's nothing that's 100% coming out of it. There's nothing 100% out of your brain. So AI systems are improving over time significantly. We think with the addition of things like quantum computing that can do the analysis even faster, you're going to see some advances very quickly. But everyone here knows more today than they did when they graduated from college. AI is the same. It's in its not quite nascent, but it's in its early stages, and it's exponentially making differences already. Systems and neural networks are getting better and better, but right now we think that's an augmentation for the human decision. So to summarize the trust aspects of this, context is important, understanding what you're looking at in context. Training and data models are important. Are the people doing the training biased? What are they bringing into the decision making? What's going on with the models and how are you defining them? What's the data and the data quality coming in? Have you made sure that your data is not biased on the front end? Eliminating that bias is really critically important. And then just the ethics, the trust, and that transparency across that is really important. We've got several systems that we've built that are now open source that do this. Several other companies do too, right? So you want to look at AI explainability. We have a 360 toolkit, a fairness kit, an adversarial robustness kit, right? So we've got things built where you can test your data, you can test your training, you can test your models, you can test your results for bias and ethics. And with that, I think I'm going to turn it back over. About time.
Great. Thank you very much, Susan. All right, next up, we have Dr. Harbir Untitled, who is the founder and director of the Center for Mathematics and Artificial Intelligence here at George Mason. He's also a Department of Mathematical Sciences, again, here at George Mason University. Dr. Untitled?
Thanks, Chris. Can you see my slides?
Yes.
Okay. Well, thanks to all the organizers and all the speakers. It's a pleasure to be here. So I'm going to take a slightly different perspective, but try to complement what has already been said. We're trying to do several things related to AI and machine learning in our group, and I will discuss some of those projects very quickly. Our research in particular is funded by National Science Foundation, Air Force, Navy, and DTRA. So I'm a mathematician by training, and my research focus is in optimization and differential equations, and more recently, we've been trying to apply some of these machine learning tools to solve the problems that I have looked at previously. Chris, can you see the second slide? Sometimes it gets stuck.
Yes.
Okay, good. So I just want to quickly start by answering the question, which we already heard some of these things earlier, that what does the machine learning do? What is AI trying to do? Basically, you're trying to teach a computer program to perform a certain task. And you're not trying to do that by some explicit instruction that you please do this, but computer is actually trying to learn what to do by going through the data, or is trying to learn from the data. So that's sort of separates us from what was being done earlier, maybe in the last decade. So, and of course, machine learning helps us create also models, which we're going to be used for prediction afterwards. And it helps us create certain rules. And eventually it enables computers to execute complex tasks. But that's not it, right? So when we try to learn something, it's not simple memorizing. We need to generalize it as well. We should be able to apply it to some realistic applications. So that's like the true learning. And that's what is known as generalization or prediction when it comes to machine learning. So on the right, you see a picture of a typical neural network. So in our group, we actually tried to open this black box that Susan mentioned in her opening remarks, so this is a typical neural network where you have one input and one output and a few hidden layers. So what is going on behind these hidden layers? So we try to develop mathematical models for these things. Of course, there are challenges when it comes to neural networks. I mean, we are trying to learn from the data, and what we expect, it can be only good as the data that you have. I think Susan also hinted that in her speech. And there are further challenges. Can lead if your data is biased, for instance. So it could lead to some demographic disparities. So this is my sort of the workflow that I try to undertake when I'm doing some machine learning or AI. The first stage is you try to collect data from some measurements, and the second stage is the learning. But we term learning or machine learning or AI is a very general term, but there are actually specific algorithms corresponding to the type of data that you have, and type of output that you want to have. It's very different to classify images, so machine will be different to classify images than if you want to solve a differential equation, for instance. So if you're given like a lot of data, correspondingly you're given some classes, this is known as the so-called supervised machine learning. But if you're not given labels for your data, then it's known as unsupervised machine learning. And then there are examples of semi-supervised learning that are given some amount of data. An example is this something called GAN, or this generic adversarial network. So third stage is what we call prediction. And there is no actually magic behind it. From a mathematical point of view, what you're doing is something called interpolation. So I'm not expecting everybody to know this term at the moment, but you have trained, you've generated some sort of function or some machine on the existing data, and you're trying to figure out what happens if new data comes in, what are the outcomes. An example is a classification if you want to determine if an email is a spam or not. Or another example is regression. For instance, if you want to assign some sort of risk score to a defendant, or if you want to retrieve some information. But of course, so this third stage is the action that we are taking. But sometimes there is a feedback that comes in. It can be unintentional, or it can be because of some adversary. So when you click on a YouTube video, right, it gives you preferences afterwards based on the choice that you made. So that's what I will call feedback. So that's like typical workflow in machine learning or AI. In our group, we are looking into various applications, especially in physics applications and also in imaging and some related to health. For instance, we are looking into so-called chemical reacting flows. These are some particular applications are combustions or hypersonic flows or explosions. This project is funded by DoD. And then there are some other applications we look into: cooling of thermal fins, groundwater flow, contamination, some weather prediction application we started looking together with the postdoc recently. These first three applications, they really amount to solving large differential equations, and many times over. It can be a very cumbersome task, actually. We're trying to see if we can use AI and machine learning to speed this task up. Then we have application from the image side. So we're collaborating with a company called Black Sky, where this is a satellite company, and these images the data that you get from satellite can be really large. And you want to detect some objects, you may want to do some segmentation, or you may want to enhance the resolution. It's actually a rather challenging problem. We have a new center at George Mason University Center for Drug Discovery, and we're starting to collaborate with them. It's in very preliminary stages, this project, trying to understand what role can AI play in drug discovery, and how can AI actually overcome health disparity. So we have seen that there is huge health disparity in the United States over the last year or so because of COVID. So just to show you an example of what AI can do, the left image that you see in the bottom row is taken by a satellite, and you want to segment the houses out of that. That's what you see in the middle. So the machine that I generated using neural network, I've shown the structure of the neural network at the top, but that's not so important. But what you get is the picture in the middle. On the right, we want to extract aeroplanes, and it does a pretty reasonable job, actually. The situation can be even more complicated. So here there are two rows on the right side. The top row and the bottom row, the left images are taken by satellites, and we want to segment out roads. And if you look at the bottom image, even the top image is not so immediate, actually, if you can segment this out. So AI is playing a significant role there. And I already mentioned, we are also looking into the role of AI in drug discovery. So, of course, there are many challenges, as already been pointed out. So when we collect some data, and this final decision maker may not be involved in those measurements, for instance. The data may not be sufficient, or it may not be sufficiently diverse for training or for testing your neural network. The learning algorithm may generalize based on the majority culture, leading to high error rate in minority groups. We can ask this question that Susan raised: is machine learning AI, are these solutions sufficiently robust or resilient, or can we trust them? And I would say not always, actually, especially in engineering problems. They are starting to play a significant role, but still we are way off. Let me give you a very simple example. So in this picture that is shown a lot, actually, you have a stop sign, but if you just spray paint the stop sign with some speed limit, it's not clear if your self-driving car is going to actually stop, or if it's going to go that at the speed that you spray painted on. Could really potentially lead to a very bad accident. And what's missing from a mathematical point of view, so this is an example of an adversarial attack. So what's missing is these problems in mathematical terms are typically ill-posed. So if you make a small perturbation in your data, a small change in your data, that can lead to a significant change in the output. And this small perturbation that you're making may be imperceptible to the human eye. People are trying to develop new algorithms to overcome these challenges. So they deliberately introduce some attacks when they're designing an algorithm. People are trying to use some game theoretic ideas where there is an adversary and there is an actual player, and how they compete with each other when they are doing this so-called training. But I mean, as everybody else, I'm also cautiously optimistic. I think there is some hope out there for the engineering problems that I'm particularly interested in. In particular, it can, so machine learning has shown some early signs of promise to overcome the so-called curse of dimensionality. So the problems that we work with are fraught with uncertainty, and this can be high dimensional problems. Machine learning can play a significant role there, but I think we are not there yet. There is a long road ahead. So that's what all what I wanted to say. Thank you.
All right. Thank you very much. Finally, batting cleanup, we have Charles Kim, who is director at the Office of Petitions and co-chair of the AI and IP Policy Working Group at the U.S. Patent and Trademark Office.
Thank you, Chris. Can everyone hear me okay?
Yes.
Okay, awesome. So good afternoon, everyone. As Chris mentioned, my name is Charles Kim from the USPTO. First, I'd like to thank George Mason University's Center for IP and Innovation Policy for inviting me here today. I was listening to Ryan's remarks earlier today, and Ryan touched on several activities that I'm planning to discuss. So I apologize in advance if there's any redundancy. Unfortunately, I don't have any slides for today's presentation. However, all of the information that I provide today is available on our AI webpage on the USPTO website. So hopefully that'll create some incentive for you to take a look at our AI webpage if you haven't already done so. The USPTO has been very active in the AI space, and we have grouped our activities into two categories. The first category relates to leveraging AI technology to help enhance our internal operations at the USPTO. The second category relates to AI intellectual property policy. As Chris mentioned, I am the co-chair of the USPTO's AI IP Policy Working Group, so I can better speak to that second category relating to AI IP policy, but I will provide a high-level overview of how we're using AI as a tool at the PTO to enhance our operations. So with regards to that first category, using AI as a tool, one of the core functions of the USPTO is to review and examine patent and trademark applications. And we're leveraging AI technology with regards to patent examination in two critical areas. The first area, Ryan mentioned earlier, we are leveraging AI technology to classify the incoming patent applications that we receive. So every year, the PTO receives hundreds of thousands of patent applications, and every single one of those applications have to be classified. We assign each application what we call a CPC symbol. And the reason why we classify every application is, one, to ensure that application is assigned to the appropriate examiner, the examiner that has technical understanding relating to that application. And the second reason why we classify every application is for search purposes. Once a patent application is filed and that application is published, that application can be searched by an examiner as part of the prior art search process. And that leads me to the second critical area where we're leveraging AI technology for patent examination purposes. Prior art search is a critical component of the patent examination process. It ensures that it helps to ensure that the USPTO issues patents that are reliable and predictable. One challenge that our examiners are facing is that the scope of prior art that is available is growing exponentially. So to help our examiners kind of sift through this large amount of prior art that's available, we are leveraging AI-based prototype search tools to help our examiners identify relevant documents quickly. And our AI search systems can also provide suggestions to our examiners for additional areas to search. We're also exploring AI for image searching, which is really important for our examiners that examine design patent applications. Our examiners that examine design applications primarily rely on image searches as part of their search. So we're exploring AI to help our examiners find relevant prior art based on image searching. On the trademark side, the trademark examination side, we are similarly leveraging AI technology for classification and search purposes. We have also developed a prototype of an AI-based chatbot for answering frequently asked questions on the USPTO website. And we are currently beta testing this prototype chatbot. I do want to point out that with regards to all of our AI tools at the PTO, the uses of these AI tools are strictly non-dispositive. We build AI tools to complement and to empower human experts, that is our employees at the USPTO, and our employees remain in the driver's seat as the decision makers, and we continually monitor the outputs of our AI tools. Now, moving on to the second category relating to AI IP policy. As I mentioned earlier, we do have a AI IP policy working group at the PTO, and this working group was formed back in 2019, and it's made up of AI experts from across the agency. This working group has been involved in several initiatives during the past 2 to 3 years. So, for example, back in January of 2019, we held an AI conference at our headquarters in Alexandria, Virginia. It was an all-day conference that featured panels featuring IP specialists from around the world. And these panels covered a variety of topics, including patents, copyrights, trademarks, IP enforcement, global perspectives, and the economics of AI. In August of 2019, we issued our first, one of 2 requests for comments. The first request for comments focused on patent policy issues relating to AI invention. So we sought feedback and comments from our stakeholders on issues such as inventorship, which Ryan talked about previously, as well as patent eligibility and the disclosure requirements of AI inventions. So Susan mentioned that some AI systems are like a black box, right? So how does that affect the disclosure requirements when you file a patent application? We also asked questions with regards to how AI might impact the hypothetical one of ordinary skill in the art. So those are some issues that we had sought feedback on in our first request for comments. And in response to that first request for comments, we received almost 100 comments from just a wide range of stakeholders. Later in 2019, in October of 2019 specifically, we issued our second request for comments. And this second request for comments focused on other non-patent IP policy issues, such as copyright law, trademarks, trade secrets, and new forms of data protection. In April of 2020, the USPTO issued our final decision, a final agency decision in one of the Davis cases, and Ryan discussed these cases in detail, so I won't spend too much time regarding that case. And in October of 2020, so about 1 year ago, about 12 months ago, the USPTO published 2 reports on AI. The first report is titled Public Views on AI and IP Policy. And this report essentially summarized the comments that we received in response to the 2 requests for comments that we had published in 2019. Some general themes that came out from the comments that we received are AI has no universally recognized definition, which was discussed previously. And because there is no universally recognized definition, our commenters cautioned that we be very careful if we develop specific IP policy regarding AI. Other commenters indicated that the existing current US IP laws are generally calibrated correctly to address the evolution of AI technology. Many of our commenters also encouraged us to keep a close eye on legal and scientific developments in AI to ensure that the US maintains its leadership in this critical technology. As I mentioned, we published 2 reports in October of 2020. The second report is titled Inventing AI, and that was published by our Office of the Chief Economist. And this second report finds, among many things, that AI is diffusing broadly across technologies, inventor patentees, organizations, and geography. The report also finds that the number of AI patent applications have more than doubled from 2002 to 2018. More recently, earlier this year, in June of 2021, we made public our AI, what we're calling our AI patent data set. And this data set is a collection of over 13 million patents and published applications. And we identify of those 13 plus million patents and published applications, which ones involve AI technology. And the reason why we made this data set publicly available is to help researchers, policymakers, and the public explore the impact of AI on invention. Later this month, the USPTO, along with the US Copyright Office, is planning to hold a joint event on machine learning and copyright law. The event will be held on October 26th, and it will include panel discussions that will explore machine learning in practice, as well as how existing copyright laws apply to the training of AI systems. As I mentioned before, all of the activities and the initiatives that I just discussed is available on our AI webpage, and that AI webpage can be accessed through the USPTO's main homepage. So with that, I'll turn it over back to Chris.
All right, great. Thank you very much. And now we have the first of the many moments that you've all been waiting for, which is your first MCLE code for the day. The code for this panel is HAL 9000. I'm sure you all understand the reference, as in, I'm sorry, I'm afraid I can't do that, Dave. So it's HAL 9000, one string, Hotel Alpha Lima 9000. I think it will be put into the chat as well. And we want to start getting into some questions. We have a good amount of time left. I'm just going to throw out one sort of big picture question to the panel, maybe to get the ball rolling. And again, I encourage everybody to write any questions that you have in the Q&A panel. But the question I have, I think it might be helpful if we can, get your combined theoretical and practical expertise to sort of try to address this. Because one might still ask, even having listened to like Woody's presentation and stuff, and say, well, what is it about AI that's really radically discontinuous from technical aids to calculation or to figuring things out that humans have been using for a long time, ever since we had things like compasses and eyeglasses, and then later on X-ray machines. In other words, if AI, in fact, ultimately is just a machine that has to work within parameters that are set by humans, aimed at particular problems that humans are interested in, and all the AI can do is sort of spit out some, it's very sophisticated, of course, but all it can do ultimately is spit out some sort of information that then human beings are going to decide whether it suits their motivational purposes or not, and either choose to adopt and use or not use or ignore. What is it exactly about AI that, that requires us, possibly to radically rethink, how any of these are the way that we normally think about things like invention or authorship, the things that Ryan was talking about? Because I could imagine somebody just saying, well, at the end of the day, a human being is going to have to decide whether the invention is actually worth using or the artwork that's generated is worth listening to. And so there's going to be some human being that has to adopt it. And that might require some tweaking of the way we do IP policy. But there's nothing here that's, that ought to shake the foundations of our thought about things. I'm curious, maybe, can anybody tell me is there something about this sort of, maybe oversimplified view of AI simply as a souped up tool that humans use? What am I missing? Am I missing something in that description that really needs to be? I'm asking if we can pinpoint whatever that thing might be that we really need to pay attention to that renders AI fundamentally disruptive. Anybody on the panel, do you have any thoughts on that, Woody?
Yeah, sure. I do. I think the thing that's interesting is that our paradigm has been that humans are tool users. We develop tools. If you look at humans 200,000 years ago, the tools that we developed then, were, it's a history of development of tools, and the tools were always something that we created. They were something different than us. We were human, and the tools were tools. But I think that boundary is blurring, and I think artificial intelligence is in some fundamental way changing the boundary between human as human and tool as tool, and it's because AI is becoming more human-like in its thinking and its behavior, and even with humanistic appearing robots and how it looks. So I think that's a fundamental paradigm shift in technology itself. And I even go so far, I didn't say it in one of my slides, but I make the point, I try to make the point that we are becoming the technology. We are essentially have the ability to put so much AI within ourselves that we become the technology. But anyway, I mean, so basically the boundary between humanity and tools, AI tools, I think is blurring. And I think that's what's stressing the law. I think that's what's stressing morals and ethics. And I think that's something to think about as we go
It's
forward.
interesting. I'm sorry, go ahead.
That's it.
I just, in response to what you just said, that's really interesting. And it seems to me that in one respect, that might also almost obviate the problem, right? That to the extent that we get to the point where AI is integrated with humanity, I'm not sure exactly what form that takes. I'm not that familiar with my singularity lore, but my understanding of it is that, if at some point, some form of artificial intelligence is so well integrated, just like I might have an artificial hip replacement, I have an extra lobe of my brain that can use, harness AI power. At that point, it no longer becomes a question whether I'm the author or if the AI is integrated into me, then this question as to, well, who's really the author or the inventor, me or the AI, sort of goes away, doesn't it? At that point, it's just, yes, we're all enhanced human beings who have greater capacities, but doesn't that put us back where we were at square one in terms of asking, well, who's doing the inventing or who's doing the thinking?
It does. And I mean, and if you think about, if you're familiar at all with the work on neuroprosthetic devices and the fact that researchers at MIT have taken the memory, recorded the memory at the level of circuits from one rat brain, transferred that into another rat brain, essentially transferred one memory from one animal to another animal that never experienced that, but has that memory. So if you have a neuroprosthetic device in your such as an artificial hippocampus where memory is stored, and they're trying to develop that to treat Alzheimer's disease. So there's a medical application. That's what's motivating this. But I mean, if in the future with further developments in technology, if you have an analog brain and you have some parts of the brain are digital, and what if the digital part of the brain is creating copyrightable work, or it's creating patentable work, and it's getting downloads from some external source. I mean, that really makes the question of who's this is actually a forward look, thinking conversation here, but that really makes the issue of who's the author, incredibly interesting and challenging, I think. I mean, I don't know. I mean, I could put, what if I put the thought in your mind? If I actually put it at the level of your synapses, I mean, maybe that could be technologically possible.
Did anybody else on the panel want to weigh in on this, Harbir?
Yeah, I can add a little bit, actually. I mean, one example is self-driving cars, right? So where you have to make real-time decisions, actually. So it's not that the AI produces something and human can intervene, but the self-driving cars will be making real-time decisions or are making real-time decisions, which requires interaction between humans and machines in some way, right? Because even if one wrong decision can have significant consequences. I mean, in an aeroplane, there are stabilizing mechanisms, and humans are not going and intervening. They're automated. So this is something that we have to keep in mind that sets us apart from what was being done before. So these decisions are real time and they are consequential. So we have to make sure that if we are using this, that these decisions are done robustly. There's something we can trust.
Mm. Yeah, that's an important point. I think there's an important distinction, I think, between setting parameters to a machine to go get you information, which then you're still going to evaluate the output before you act on it, and giving a machine decisional capability to cause actual things to take place, like stock trading or driving or, drones who are going to shoot the Hellfire missile at the enemy or something like that. Or that obviously makes a difference. All right, so we've got some good questions coming in the queue. I think I'm going to pick the one to start with, which is the most adjacent to what we just started talking about. There's a question that says, is it expected that human inventors that are not augmented by AI, I take it we're going to have some transitional period during which not everybody is augmented, and maybe not everybody ever will be. That's another interesting future of society / economic equality question, I suppose. But is there a reason to believe that at some point we would have some inventors who have AI and some who don't, and the ones who don't will be marginalized from being able to do any industrially important innovation? I mean, this is one that I think anybody on the council could equally well speculate on. Does anybody want to weigh in?
I think it's a very interesting concept, right? I don't think everybody's going to have AI accessible immediately, just like in the beginning, not everybody had a computer accessible in the beginning, right? It's getting more and more ubiquitous as we go, and will continue to. So you'll see AI in everything that you touch. It's in your iPhone, it's in your car, it's in everything going forward. And you will see a disparity between kind of the people that do have access to that and the people that don't. It's an interesting dichotomy that we need to think about as we go forward.
I actually want to interpolate here another question of my own. I'm going to focus it first of all at Dr. Antil. And again, if anybody who has thoughts is welcome to weigh in. But I'm interested in, are there certain things, given that at the end of the day, AI is math, and this is why I'm addressing Dr. Antil, because he's our key math expert here today. Are there certain things, what are the limitations of math? Are there certain things that we cannot expect AI ever to be able to do, given that in order to do them, you have to create, in effect, a digital model of the world, and the world is analog, and a lot of things that human beings care about arguably are analog. And is that a meaningful distinction, that there are certain things that there are outer limits of what you can do with numbers and math and zeros and ones, such that there's certain things that AI is not going to be able to take over? Or is that just a pipe dream of somebody trying to retain some vestige of humanity that's going to be outside this stuff?
Right. So basically, this AI or machine learning problem is actually, in terms of mathematics, it's an optimization problems, and there are some laws that optimization problem has to fulfill. There are some constraints that you have to deal with. One of the fundamental challenge here is that these are very high dimensional problems, and they are what I call the non-convex problems. So these are not typical optimization problems that we solve on the daily basis. So a lot of infrastructure that we developed over the years, in the last 20 or 30 years, was developed for a slightly different classes of problems. But now we are going in sort of uncharted waters. That's why we have there is a hope of developing even new mathematics and new optimization algorithms. And also simultaneously, there is another revolution that's happening, which is on the computer side, right? So we're getting more and more GPUs, more and more CPUs, so our computational capabilities are also growing. So I mean, it's not an easy question to address at the moment, that if AI going to be able to solve all the problems. I would say there is a hope that we can tackle some of the problems. So for example, I won't trust an AI at the moment to solve a very precise engineering problem. Like if you want to design a bridge, right? Is it going to be able to take into account all the factors that an engineer takes into account? So to design a bridge, right, you need to account for your elasticity equations, and you need to have a precise mathematical model which you do basically some mathematical simulations, and like even very small numbers makes a big difference. Actually, I'm trying to be less technical here, but AI in that sense is still crude. Because I mentioned these are highly difficult optimization problems. They're non-convex. So what that means is the solutions you are getting, they are not your sort of globally optimal, global minimizers, but they are some sort of local optimizers. So how do we reconcile these two differences? So how do we make your machine learning methodology more robust and more accurate? So that it's comparable to the existing technology, especially from the engineering point of view. So I don't think we are there yet, but we are taking steps towards that direction. So it's sorry, I'm not answering your question directly. I think there is a lot that needs to be done to address this question if you're going to be able to solve the problems. Because at the moment, we are not able to solve the existing problems that we can do using traditional approaches, using AI and machine learning, but we are taking steps. So we are really in the early stages. As Susan mentioned, right, when computers came in, I mean, we were doing very, very basic operations, and that's what we are doing with AI and machine learning at the moment.
And I think you need to think about where computing is going to, right? So computing right now is zeros and ones. And as we move into quantum, that opens an entire new mathematics area where we can go into that we've not been able to do before. So it broadens what you can solve and how you can solve it. So it's no longer just yes or no. It's not just black and white. There's all the gray area in between at the same time. So not to get deep into quantum, but there are some things coming in the quantum area for AI that will accelerate some of this and change the way that we think about it.
And that will require even further investment, actually, because our traditional algorithms, they were developed for GPUs and CPUs, but now if you look at the quantum computer, it's a whole different ball game.
So we're at the beginning.
Yeah.
Okay.
So I think it's really interesting when I hear my co-panelists say we're at the beginning, and I feel that's also the case. So it's interesting. So if you think about it, look at all the things that AI can do, and all the incredible advances, and we're just at the beginning. And so, I mean, this is the conference about intellectual property law and how it relates to artificial intelligence. So the law is already being stressed by capabilities of AI, and we're just at the beginning, as the panelists keep saying. So that really makes you wonder what's going to happen in 5, 10, 20 years. How will the law be stressed? How will we regulate? How will we enact laws? How will the patent office respond, and so on? So again, it's really interesting. We're just at the beginning, but we're at the beginning of that. And if I could throw in some of my futurist ideas, I mean, here we are as human beings. We've got 100 billion neurons, 100 trillion synapses. Well, we're going to still have that 100 century from now, but AI is not going to stand still. So that's something to think about.
Okay. Well, so here we have another good question, which maybe is a more concrete applied application of this very problem that you've been discussing. So we have a questioner who's wondering, how do we think AI is likely to affect determinations of the level of skill and ordinary skill? Now, these are references to patent law. Obviously, we're talking about sections 112 and 103. How do we think, and this would be an interesting question to hear from Charles and Susan, I think, who are more directly involved in patent law issues. How do you see AI affecting determinations as to what the level of skill is? Is that something that's reared its head yet that you have to really think about? And how do you see those kinds of issues coming down the pike?
So Susan, would you like to go first, or would you like me to?
Go for it.
Okay, all right. So for those that may not be aware of this concept of a person of ordinary skill in the art, a person of ordinary skill in the art is a legal fiction. And this person is presumed to know the relevant prior art. There are several factors that are considered when determining the level of one of ordinary skill in the art. And those factors include the type of problems that are encountered in the art, prior art solutions to those problems, the rapidity with which innovations are made, the sophistication of the technology, and the educational level. So these are all factors that are relevant in determining the level of one of ordinary skill in the art. And every case is different, right? It is very fact specific. And this is one of the issues that we actually addressed in one of our requests for comments. And in response to this issue, we received comments kind of on both sides, right? So we received comments from folks that indicated that AI does have the potential to affect the level of ordinary skill in the art. The one commenter indicated that just as the existence of test tubes impacts the level of ordinary skill in the art, in the chemical arts, and just like the existence of general purpose computers impacts the level of person of ordinary skill in software arts, right? AI can also have an impact in the level of one ordinary skill in the AI art. So that's kind of one view, and other commenters indicated that that AI is still very much in the early stages, and it has not yet permeated all fields. So it's a little too early to say that AI has made an impact to the level of one of ordinary skill in the art. So there are definitely diverging views on this issue. And as I indicated, this is a issue that we have addressed in our request for comments, and our report that includes the question as well as the comments that we received in response to this question can be found on our website.
Is this something you've had to think about yet, Susan?
Yeah, we've thought about it, but I don't think I have anything in addition to add to what Charles just said. It is early on, but it's something that we need to start thinking about now, as opposed to 5 years from now, because it's moving fast, right? But we don't see it yet.
Is it likely that, I mean, the questioner is also posing a sort of a follow-up. Does it seem likely the one way to deal with that would be to differentiate between different categories of inventors? You know, for example, if it was an AI invention like the one that Brian showed us in his presentation, as opposed to a human who's claiming the inventorship, we might have to have differently calibrated levels of skill, or?
I hope not.
So just to build on Susan's point, I think we don't want the law and regulations to get too far behind the technology, right? We also don't want the law and regulations to get too far ahead of the technology as well. So I think, we at the PTO, we're trying to be very careful as we study these issues, and we've been engaging with our stakeholders, and we're in discussions right now about next steps, right? I discussed some of our activities, and we have an event coming up later this month, and we are in discussions right now regarding next steps. And I can't get into the specifics of what those next steps are or will be, but I think it's safe to say that there will likely be further stakeholder engagement on these issues. So these are issues that we are still looking into, and we're carefully studying, and we will likely be continuing to engage with our stakeholders as we move forward.
Great. All right, I'm looking on the chat. I don't see any more questions in the Q&A. Does anyone on the panel have any other thoughts that occurred to them in response to anything that's been said so far that you'd like to throw out there?
I want to make a comment to the panel, actually. There's something that I always wonder about. I mean, I'm constantly learning too. So, I mean, there are, research waves, right, that comes and goes. But the waves that the way we are in right now with AI and machine learning, this feels a bit different. And it seems like it's going to stick around for a while. I mean, I see already, as I mentioned in my talk, I already see potential of working in this direction. Just want to hear some sort of comment from the panel or from you, Chris, if you have any.
You seem to have stumped us.
I think we're going to continue down this path, right?
Yeah.
We're working obviously with the MIT lab on all kinds of things around AI and implementations and ethics and everything else. So I think it's come a long way. I mean, AI's been around since the 50s. to be honest. So
Right.
it isn't like this is brand new, but it is because of compute power, because of a lot of the things that have happened in the last 20 years, it's accelerated dramatically. And understanding natural language and understanding some of those things has come a long way. But I still think we've got a long way to go to your point.
Totally. Thank you.
And I'll just add that that discussions around AI are taking place at the highest levels of government, both within the United States as well as in other countries. Within the U.S., we have a what we call the National AI Initiative, and that's the U.S. National AI Strategy. And there's several pillars to the National AI Initiative, and more information. I don't think we have time in this session to get into details about that effort, but more information about the National AI Initiative can be found on ai.gov.
Yeah.
Okay, great. We might be able to sneak in one more quick question, which just came in for Susan regarding your experience using AI or machine learning in prior art search. Are there any particular things that, if I'm understanding the syntax of the question correctly, the question is, are there certain things that AI doesn't know or will overlook in doing a prior art search?
So AI is trained, right? So in some areas, if it's a brand new technology that there isn't a lot of information out there, and you haven't trained your AI system to really understand what that means and understand it, you're going to have a learning curve. Just like when you learn something at the very beginning, you know a little bit about it, but you may have a master's degree in it. But 20 years later, you've got a ton more experience and a ton more depth about what you're looking for. AI is going down that same path. So it's learning as it goes, just like a toddler would learn, just like any of us would learn. But we've been using it for prior art searches and actually been getting more results. But this is why we're still keeping a human in the loop here. We want to be able to say, is it catching the things we think it should catch? It's giving us additional ones, which is always good to know because of the natural language, because of the neural networks. But are there things it doesn't know? Absolutely. And that's where continual training comes in and continual feedback comes in of, yeah, that's right. No, that's wrong. Here's the context you're missing. All of those things need to be included in your training. And context, I'd say, is one of the biggest ones.
Okay, great. Well, thank you. I think that's all the time we have for this panel. So I want to thank all of the panelists and turn it back over to Sean.
Hey, thanks, Chris and the panelists. That was just a fantastic session. I think we really got a lot deeper into the technology and what's going on with AI. And we're going to take a short break now. I think we have about 20 minutes, and we'll start up again at 3:50 or 10 minutes before 4 o'clock. And then we'll have one of my other colleagues from Scalia Law, Professor Donald Koshan, who is the Deputy Executive Director for Law and Economic Center. He will run the next panel again, starting at 3:50 or 10 minutes before 4 o'clock. See you all soon.